Okay. So our next question is asking us what points that's the function 25x squared plus 16y squared plus 200x minus 160y plus 400 is equal to 0. Alright. Oh, what points does a function have a vertical or horizontal tangent line? Okay. So first thing we need to know is the slope of the tangent line. Okay, and the slope of the tangent lines is equal to the value of the derivative at that point. Okay, so let's write that down. So that is equal to derivative, or we use dy dx to present as well, the derivative at that point. Okay, and second thing we need to know is if we talk about horizontal tangent line, its slopes is equal to 0. Okay. Since slope is also equal to rise over run, and since it's horizontal, so that means the rise part is equal to 0, and 0 over run is just equal to 0. So that's why the slope for horizontal tangent line equals to 0. And we have lastly vertical tangent line. So the slopes for vertical tangent lines that are undefined, or we say with 0 denominator. Okay, so that's the 3 things we need to know before we're solving this question. And now let's go back to the actual question. And we're going to approach this by getting the derivative of the function by implicit differentiation. Okay, so by implicit differentiation, okay, so let's copy down the question again. All right. Okay, so we have 50x plus 32y dy dx plus 200 minus 160 dy dx is equal to 0. Okay, since for the first part, we just move 2, the exponent part, to the constant. So 25 times 2 is 50. And so similar for the second part. Other than moving the exponent to the constant part, we also need to take the derivative for y. So that's why we have a dy dx here. And yeah, so similar thing for 200x, just 200 itself. And yeah, so for 160, we also need to take the derivative of y. And the derivative of 400 is just equal to 0, so we didn't write that out. Okay, so coming up, we have dy dx is equal to 200 plus 50x over 32y minus 160y. I mean, just 160. There's no y left. Okay. Yep. Okay. So now we can solve for the tangent lines. So for horizontal tangent line, tangent lines, the numerator must be equal to 0, as we talked earlier in this part. So the numerator has to be 0. The numerator has to be equal to 0. All right. So we have 200 plus 50x is equal to 0. As that is our numerator part. And 200 is just equal to 50 or negative 50x. And x is equal to negative 4. Okay. So second, we have for the vertical tangent line, vertical tangent lines. The denominator has to be equal to 0. Okay, so the denominator is 32y minus 160, and that needs to be equal to 0. So we have 32y is equal to 160, and y is equal to 5. All right. And yeah, so after solving x and y, we substitute this value to get other x and y values. Substitute. So let's copy down the original equation again. Okay, so 25 times negative 4 plus 16 times y plus 200 times negative 4 minus 160 times y plus 400, and that will also give us y is equal to 0. Okay. Yep. Oh, Oh, and there's one more. Oh, there's one more. So for this one, 25x squared plus 16 times 5 times 5 squared plus 200x minus 160 times 5 plus 400 is equal to 0, and x equal to 0. Okay. So the points should be negative 4, 0, and 0, 5. Yep. Okay, and let me just label this. So this is for horizontal tangent line, and that is for vertical tangent line. Okay. Yep. So let's just review this question one more time. So first, we need to know what a slope of the tangent line is. Okay. And then we need to know the characteristic for horizontal tangent line, which the slope is equal to 0, which also means the numerator part is equal to 0. And on the other hand, the vertical tangent line, so the slopes for vertical tangent line, they are undefined, or we say with the 0 denominator. So the bottom part should be 0. And then we solve this by implicit differentiations. So just remember, when you take the derivative of something related to y, also take the derivative of y. So that's why we have dy and dy dx here. Okay, and then we just substitute the number in after we getting the after we're letting the numerator and denominator each equal to 0 to find out our horizontal tangent line and vertical tangent line. Okay, yeah, and that is our answer. Okay, let's leave a comment. Solution is correct. Well done.